Hello, you guys. It is me saying, you guys, I'm back, y'all, for some more coding, of course. So just let me know down below in the comments below how y'all are feeling. How are y'all doing? Yes, it is October, you guys. It has been a while since I made a video. It has been some time. We're doing like sets in Java, so this is a quick tutorial, just going over sets. A few slides provided by APlesComps, I believe. They're pretty good slides I have. They go over sets pretty well. I'll show the basics. I'll tell you some of the important topics that you should know, some of the things that don't really matter as much, so we'll kind of glance over those, but you'll have a good understanding of it. So let's go and take a look at sets in Java. And yeah, and just one comment down below as to like how the process went for y'all, like from start to finish of just your coding journey, your story, whatever happened. Definitely interested to hear that. Are you helping out people in Python like me or what? Because we've been through a lot, y'all. And this is like the next thing I feel like we should know. So let's begin. Alright. Let's do this. Sets in Java. Alrighty. And of course, if you have any questions, ask me in the comments below. Yes, of course. Alright, then. Let's do this. Excited, y'all? You excited? Y'all know sets in Java? Are you sure you know the sets in Java? Or is it just a general thing? I don't know. Depends on the person, I guess. A lot depends on the person. But it could go either way anyway. So, let's take a look at this. Alrighty. Alright, we're good to go. Alright, here it is. Sets in Java. Algorithms and data structures. Collection interface, set data structure, operations, and the big O. So just a couple of different topics that we're going to take a look at, alright? Let's do this. First and foremost, we have the following are the important interfaces included in the Java language: collection, set, and map. So take a look at this diagram over here of the Java collections. We have the collections, which is part of the Java collections, of course, and it's a sub-interface which extends. So the collection is an interface, and our sub-interface is extending the collection is list and set. And our implement classes for list are, you may have used them before, array lists. You probably know what a list and array list are. Linked lists and vectors. So array lists and arrays just in general probably like the main ways storing data. Strings are also some of them, but there's some other ways. A set, for example. So a set is an interface. It's a sub-interface which is extending off of the collections framework, I think. And the set has some of its own implementing classes, which are abstract set, hash set, and linked hash set. You can instantiate those because those are not interfaces; those are classes which are implementing the set interface for you, so you can instantiate those. And then the set's other sub interfaces extends is a sorted set. So the sorted set is a sub interface which is extending from the set interface, and the implementing class for the sorted set is the tree set. Tree set is a class which is implementing the sorted set interface. So you can instantiate a tree set. The map, however, is all the way over there, past the white line. It's interesting because think about it like this, right? It's not part of collections. The only interfaces part of collections are lists and sets. Maps, however, just big old things just in the vastness of space of the Java collections, right? So map, and then you have the implementing classes for map. You have the hash map and the table map. Hash map is pretty popular, and our sub interface being extended from that, of course, is the sorted map. Of that, we have the tree map as the implementing class. All right, we're going to take a look at sets though. So the Java collection interface is part of the list and set, as we said earlier. It's the parent of that, right? So you can say like collection A equals new hash set, but you can't say collection A equals new tree map or something, or hash map, whatever, because maps are not part of collection. So the collection interface is the parent of list and set only. It's the parent of that. Like, I'm your parent. No, I'm just kidding. But it's like hierarchy, maybe ownership. You can think like that. And the collection interface has many methods, including add, clear, remove, and size. And there are others that are not shown, but there's the common ones. And so the set interface extends the collection interface. So you remember you have set, and then you have the hash set, and now the sorted set is the tree set. So the set, you have the hash set and tree set, which are classes that are implementing the set interface. So what is a set? A set is a group of items, all of which are the same type and none of which are duplicate. That means you can think of it as it is dynamic in size, so you can add stuff, remove stuff, change it up a bit, unlike maybe arrays which are static. Dynamic, reset, awesome. You can change its size using the add method, of course, in which none are duplicate. So if you do have a duplicate item, let's say you add something and you add something again, the new duplicated item is going to override the original one, and so your new one is going to be the one stored in your set. Pretty interesting to think about, right? And so yeah, and then you don't have to always specify the data type when making a set, but with the little arrow signs, but it just depends what you want it to look like. So let's take a look at this example. So because set is an interface, you cannot instantiate it. You can only instantiate a class which is implementing the set interface. So if we do set bald equals new set, that's illegal. But if we do set hash equals new hash set is a class which is implementing the set interface for us. Hence we can instantiate it. Same for the tree set. Those two are legal. Looks good to me. So starting from Java 5, you're going to specify which type of reference or data type you want to store in the tree set or hash set. So that's pretty cool. You can do the first one, set bytes equals new tree set, or set it, which is an iterator, it's equals new hash set. So those both work. So a hash set specifically is a set ordered by each item's hash code that is extremely time efficient. To further elaborate upon that, I believe it's big O is O of 1 for the hash set. It's very time efficient because it's not ordered. Strictly, there's no strict order. It's just what the Java compiler has through the hash code. So it's going to be more so in a random order. Unlike the tree set, which is a naturally ordered set, the order is in ascending order based upon by ASCII values. And that makes it still pretty efficient. I believe it's O log 2 log base 2n. But it's just not efficient as a hash set because it is random order. So it has to ascend everything in the right order. Alright, binary tree. So the tree set and the tree map are built around binary trees, hence they have the word tree in them. Binary trees are a group of nodes that contain left and right references. Each item is inserted into the tree according to its relationship to other nodes. So you have the other nodes, so you have the 2, and that's pointing to the 1 and the 6. So you can see the nodes are those left and right references. Alright, you just think of a tree. Climb up a tree, have fun on trees. Hash table. So hash set and hash map were both created around hash tables, and of course there's hash browns. You can eat them up. You have been saying hash for so long, it's on my mind now. So a hash table is essentially an array. You can think of it like that, and each item is inserted into the array according to the hash formula. All right. Now let's look at some of the set methods. So these are some of the basic set methods. These are the more frequently used ones. They're pretty easy to understand. Of course, you have the add method, so you can do your set name.add. If you do X, it'll add that item X to the set. Remove does the exact opposite. It just removes it. And we can interchange these, right? Why? Because it's dynamic in size. You can do clear, which removes all the items from the set. And you can do dot size, which will just simply tell you the number of items in the set. Pretty self-explanatory. These are some more useful methods, so I'll try to explain them. Of course, is the add all C, which adds all the elements in the specified collection to this set. You need to remove all C, then it removes from the set all of its elements that are contained in the specified collection. If you do retain all, then it retains only the elements in the set that are contained in the specified collection. And our constructors, of course, are tree set or hash set, which constructs a new tree or hash set containing the elements in the specified collection. Alright, so let's go ahead and take a look at this example. So if you have a set integer in set equals new hash set, so it's a data type of type integer, and it's a hash set, so it'll be unordered. There's no really specific order to it. We add 45 and 12 to our hash set, okay, and it's type integer, so that looks good to me. And I would do system.out.println inset.add 12. What is that doing exactly? Well, checking to see, okay, is the number 12 in my hash set? If it is, I'm going to return false. Why? Because 12 was already there. Okay, 12 already exists, so I'm going to print out false. If 12 was not there, if there was no 12 already in the hash set, when doing system.out.println inset.add 12, it would return true. But since 12 is already there, it's going to return false. Now we do inset.add 23, and it just prints at the inset in any order. We have the numbers 45, 12, and 23, and it prints in the order 23, 12, and 45. Again, there is no exact order. It's just based upon the hash code, hash table, whatever, y'all. Hash set add, kind of similar. We're just doing a string data type this time. We have AB23AB, lowercase ab, and then print on string set. Again, it's just a random order. I guess it's just going from last to first, I guess, but it doesn't really matter. Okay. Now, let's say we have the hash set that looks like this. Now we're taking a look at the remove method. So we have a double in this case for a data type, and we add the numbers 2.5, 5.8, 7.3. Again, it's any order. Now it's going last, then first, then middle. Again, the order, there's no strict order for that. And then we do system.line double set, so we get the 7.3, 2.5, 5.8. And then we remove 5.8. Okay, so let's check to say, okay, in my double set, do I have the number 5.8? Yes, I do. Removed. And notice, it'll keep the order from the first line of output printed. It's going to maintain that order. So if we just remove it, it pops to 5.8 and it's gone. Now if we do double set dot remove 0 point, well, is 0 point in my double set? Because it's checking to see if it is. No, it's not. And as you can see, it doesn't really give us any error. Doesn't do anything. Okay, well, 0 point is not in my double set. All right, fine, I'm just ignore it. I'm not going to change anything. Then we're going to print it out. We have the 7.3, 2.5, and as you can see, the 5.8 has been removed. Cool. Now let's go to the trees. I like trees because if someone asks you, okay, what is the output of my tree set, you can tell that without actually like running any code or anything. Why? Because the tree set always returns in ascending order, which is why I love it. So if we do set integer in set equals new tree set, and we add 45 and 12, and again we're doing system.line in set that at 12. It's the same thing whether you do a tree set or hash set. It's gonna say, okay, is 12 in my set? It is, so it's gonna print out false. You guessed it. Now we have 23. Now notice how the output exactly is going to be 12, 23, 45 because that's an ascending order based on the ASCII values. Now, if we do this, again, same thing, right? But just with the strings now, and numbers are first, and then you have uppercase letters because like I think capital A starts around 65. I think numbers from around like 40 something, and lowercase a starts around 97. So we get 23 in capital AB and lowercase ab. Cool. All right, now let's try the remove method. So again, we're still using the double set, type double, and removing the tree set. So we get 2.5, 5.8, 7.3. We print it out, and that is the order: 2.5, 5.8, 7.3. We remove the 5.8. We pop that off. Now when we do double set dot remove 0.0, is 0.0 in our double set? No, it is not. So it doesn't change anything. Nothing different happens. So now we have 2.5, 7.3, and as you can see again, the 5.8 has been removed. All right, now let's take a look at lambdas. So if we do set of the data type string, set equals set dot of ABC. Then we do set dot for each, set lambda output print s, so we get ABC as our output. Now we do dot remove if s char at 0 is not equal to b. So it's going to say, okay, char at 0, I have a is a not equal to b. That's true. So we remove it. Then we go to okay. Now we do s dot char at 0 is not equal to 0, and the c will also get removed anyway. So we just get a as our output. All right, and now let's take a look at the big O. Big O notation is an assessment of an algorithm's efficiency. Big O notation helps gauge the amount of work that is taking place. Okay, so it's like time complexity, stuff like that. Some common big O notations are O of 1 to the power of n, and log 2n, log 2n, log 2n squared, n cubed. So as I said earlier, for the tree set, it is time efficient. But it is log 2n. Maybe it's because of the binary stuff. And the hash set is just O of 1, so it's constant linear time, so it is way more efficient. The tree sets are implemented with binary trees, red/back trees. So notice how for the tree set, all the methods add, remove, contains, they're all O of log 2n. Or for the hash set, all the methods add, remove, and contains, they're all O of 1. And then hash sets are implemented with hash tables. All right. Some last advice I'm going to give y'all, and you can definitely code some of the stuff on your own. If you want to take a look into this as well, is don't fall behind. Obviously, visualize and comprehend the problem before writing any code. So visualize it, comprehend the problem before you write any code. Don't fall behind. Stress test your code thoroughly. Come on, you got this, y'all. Be patient. Take a break if you're coding. If you've been stuck for a while, of course. And break out the rubber duck. Rubber duck, y'all. And that's it. Just make sure you have a rubber duck. If not, it's fine. And I think that's it, y'all. So there's just some words of wisdom, okay? Remember, do not fall behind. I'm just kidding. Do whatever y'all want. Have fun, okay? But just code. Have fun coding. Enjoy coding. It's a fun process, I guess. Let me know where you guys are at with the coding stuff right now. Thank you guys so much for watching. You might code this stuff up. Stay safe and have fun, y'all. I'll see you guys next time. Thank you for watching my tutorial over sets in Java. See you guys next time.